When someone on the 80th floor of a high-rise sets down their morning coffee, the cup stops firmly on the desk. But directly beneath that desk are hundreds of feet of empty air. Gravity is a relentless downward force. It is actively trying to pull that cup, the desk, the floor, and thousands of tons of concrete straight into the earth. For the building to stand, it has to offer that gravitational force a physical, unbroken route to travel safely to the ground. Engineers call this route the structural load path. The load path is a strict sequence. The weight of the coffee cup is carried by the floor slab. The slab transfers the weight outward to horizontal beams. The beams push the weight downward into vertical columns. Finally, the columns drive the force deep into the foundation. A skyscraper acts as a continuous chain of these mechanical transfers, and the entire system is exactly as strong as its weakest link. If we look directly underneath that floor slab, we find the first receiver, the horizontal beam. Because beams lay flat across an open space, the weight of the floor pushes straight down across their length. We call these transverse loads, forces attacking the beam at a perpendicular angle. Absorbing a transverse load, a beam physically reacts by deflecting, sagging in the middle. Inside, the downward curve crushes the top edge inward in compression. Simultaneously, the bottom edge stretches, pulling apart in tension. This paired crushing and stretching creates a bending moment. The beam does not make the weight disappear. It acts as a diversion. It catches the downward pull of gravity and forces it to travel sideways until it hits a vertical support. At the end of the beam, the force takes a sharp 90-degree turn straight down into a vertical column. The column faces a completely different physical reality. It endures axial compressive forces. The load is driving perfectly parallel down the center of its long axis. A column on the ground floor carries the accumulated crushing weight of every single floor, beam, and coffee cup stacked directly above it. Under this intense vertical pressure, columns face a unique and fatal vulnerability known as buckling. This diagram shows buckling mechanics. A straight column stays stable under weight, but at a critical load, it violently warps into a curve. A microscopic imperfection acts as a hinge. The massive compressive force exploits it, pushing the material outward until it gives way. When a horizontal beam fails, it sags slowly, giving visible warning cracks. But when a column buckles, the failure is brittle, sudden, and instantaneous. Because the column is the primary vertical backbone, buckling severs the load path instantly. With nowhere for the force to go, everything above it collapses. Gravity is predictable, but the environment is not. When an earthquake hits, it attacks the foundation with lateral loads. Seismic waves push the building horizontally. The entire vertical grid is forced to sway, shear, and twist. The energy released by an earthquake is too massive for any structure to remain perfectly rigid. If a building fights the earth and tries to stand entirely stiff, the sheer force will tear its joints apart. To survive, modern architecture relies on a hardwired failsafe known as the strong column, weak beam mandate. Engineers intentionally design horizontal beams to fail first. As lateral forces peak, the steel in the beams is meant to experience flexural failure, yielding, bending, and cracking under the pressure. This is a controlled sacrifice. The breaking beams act as massive mechanical shock absorbers. They burn off the seismic energy by bending, keeping that destructive force away from the rest of the structure. Meanwhile, the columns are vastly over-engineered. They are built to outlast the breaking beams. Even as the horizontal supports tear themselves apart to absorb the quake, the columns stay intact, preventing a pancaking collapse of the floors. A skyscraper's survival relies on a carefully choreographed sacrifice. The beams are designed to die so the columns hold firm, keeping the load path open and the people inside safe.